Number 4. And then it got a little bit more challenging. Okay, so there's a whole lot going on. It's really easy to get confused in this picture. And the key that you gotta recognize is, yes, that's not a straight line. You've got two rays pieced together. So you need to be able to isolate parts of your picture. So for example, right here, I know that those are parallel lines. I know that these are consecutive interior angles. Right here, I know those are parallel lines. And those are consecutive interior angles. Now you might be saying, hey, in the last problem we saw that if we've got an x and a y and one equation, we can't solve it because we've got two variables in one equation. Correct. But first equation, second equation, you have your system available to you. So this first one, right here, this right here, those two, because lines are parallel, consecutive interior angles are congruent, I have 11x minus 1 plus 2y plus 5 must be equal to 180. I'm going to combine like terms. 11x plus 2y plus 4 is equal to 180. I'm going to bring the 4 over. Yeah, I'm going to go and do that. 11x plus 2y is equal to 176. So that is one equation I have. I can come over to this other piece over here. 7x plus 9 plus 7y minus 4 is equal to 180. If lines are parallel, consecutive interior or supplementary. Again, I'm going to combine like terms. 7x plus 7y plus 5 equals 180. 7x plus 7y equals 175. Okay? And then what I'm going to do here, here's my second equation, is now I'm left with a system. I've got two equations and two unknowns, and I need a way to solve them. So, if you want to take a stab at solving your system, you've got a couple of options. Feel free to go ahead and pause the video right now to take a look of how you might want to do that. As a precursor, we had 3 strategies last year. We had substitution, elimination, or graphing. It's your choice if you think any of those might be helpful or you've got a preference. In a moment, I'm going to show you one approach. I'll talk about a second, and then I'll leave it at that. So if you want, feel free to, actually I'll talk about both. Pause the video if you want to try again now that you've got this part set up. Okay? Assuming you're still watching, here's what I'm going to key in on. I had a hunch, which is why I pulled that calculator out a moment ago. My hunch was that 175 was divisible by 7, and it is. So here's what's going to happen. I'm going to divide everything by 7. And this problem now becomes x plus y equals 25. Okay? So if I come over here, I now have these two equations as my system. This one, 11x plus 2y equals 176. And this one, x plus y equals 25. And you now have a choice. You could use elimination. Multiply one of these by a number so that you have the same number but a different sign. And then that way you can add them up and they cancel. Elimination. You could use substitution. Solve for one of your variables to the other side and then substitute it back in. You could also use graphing. Make it easier on you, grab your graphing calculator, type them in, take a look at the intersection point. I'm going to show substitution and elimination. So, elimination would be this. I need, so option 1. I need same number, different sign. So I'm going to copy my first one. 11x plus 2y equals 176. If I want this second equation to cancel, I need the same number, different sign in one of my spots. So I'm going to turn this number right here, what I want it to be is a -2. Because if it was, then my y's disappear. Well, I can't just throw one -2 in there, so I'm going to multiply the whole row by -2. So then I have -2x plus -2y is equal to -50. I multiplied every single spot by -2. By doing that, I can come over here, add together. The x's combine to give me 9x. The y's disappear, and the numbers on the end add to give me 126. Okay? At that point, you just need to divide by 9, and you are going to get that x is equal to 14. Now that I know that x is 14, I can take that knowledge that x is 14, I can plug it back into one of my equations, and I can say that 4 plus y equals 25, therefore y must equal 21. Okay? And I have now found my answer. Depending, you might prefer substitution. Now how might that look? If I come over here, option 2, what I'm going to do is I'm going to take my second equation, x plus y equals 25, and I'm going to get one of my variables alone. If I subtract x to the other side, I now have that y equals 25 minus x. So that means anywhere I see a y, I can replace it with 25 minus x. So take my first equation up here. 11x plus 2y is equal to 176. Well, lo and behold, my y is right there. I'm going to replace this y with 25 minus x. So I now have 11x plus 2, but instead of y, I'm going to get to write 25 minus x. And now I've got an expression with one variable in it. I'm going to distribute my 2 across. 11x plus 50 minus 2x is equal to 176. I'm going to combine like terms. 11x minus 2x gives me 9x. I'm running out of board space, so I'm also going to go ahead and move my 50 over. So subtracting 50, I get 126, which should look awfully familiar. I come back over here, divide both sides by 9, and x is 14. Now, since we got the same value for x, I'm hoping you'd realize that we'd get the same value for y, and it would be 21. The point being, doesn't matter which method you use, you get the same answer because it's our intersection point. Now, we found x and y, the last part would be z. My easiest option right here would be to come in, plug x in right here. So 7 times 14 would be 98 plus 9. So I know that this angle is 107. And if that angle is 107 and these form a linear pair, then this must be 73. Okay? So we've got x is 14, y is 21, and z is 73. So hopefully that was kind of a crash course refresher for substitution elimination. Again, you saw that last year, but I know it's been a while, so I'm hoping that's a bit of a reminder.